Hello, in this video we're going to talk about significance test for a population mean, how to do the conditions, how to do the four-step process, how to use a confidence interval to draw a conclusion about a test, and doing a test for paired data. So everything we know about the four-step process for proportions is still in play. It's just going to be some slight tweaks. So our mean is the mean we're trying to estimate is mu, the population mean. So in our hypotheses, our state step, we're going to use mu instead of p. Our conditions, random and 10%, those are going to be the same, but large counts is out, and now it's normal/large sample condition. So just like we did in section 8.3, we're either going to have the population is normally distributed, the sample size is at least 30, or we have to create a graph to see if we have strong skewness or outliers. Calculating your test statistic isn't going to change with the t-distribution. It's still your statistic minus your parameter divided by your standard error. So the sample mean minus the claim for the population mean, which will come from the null, divided by the standard error. Sample standard deviation divided by the square root of the sample size. So that's just an example done out. Okay, two-tailed test, two-sided test we've talked about before. You get your test statistic, find the area under that part of the curve, double the area to get your p-value. That's what this is showing here. So this test statistic might only be negative 3.17. These are the same distance away from the mean. That's why I can just double the area in this tail to get the p-value. All right. Okay, so this would be a great time to run through this if you feel comfortable, and pause the video and then come back and watch me take a look at it. So here goes. State the hypotheses for this significance test. I see mu, I see units. This is obviously mean. The production, okay. So my null hypothesis would be that mu is equal to 320. That's what they're saying. They want to make sure that their tablets contain the right amount. So I would say that the alternative is mu is not equal to 320 milligrams. So it could be higher, it could be lower. Let's take a look at that. There you go. Oh, I forgot to define the parameter in context. So you can see here, mu is the true mean amount of active ingredient in these Aspro tablets. Condition C, was it a random sample? Yes. Random sample of 36, check. V, variability, 36 tablets is less than 10% of all tablets in this batch of production. We have no reason to believe otherwise, check. S, 36 is greater than or equal to 30, so the central limit theorem applies. Sampling distribution is going to be approximately normal. We can do a one sample t test. One sample t test. They didn't actually get into that yet. I guess I'll formalize that later. Test statistic is going to be the 319. That's the sample mean, minus the 320, divided by the sample standard deviation, 3, divided by the square root of 36. So the test statistic is negative 2. So we're 2 standard deviations below the mean on the t-distribution. I'm going to use t-CDF, and I'll show you how to use that. So second vars, t-CDF number 6, similar to normal CDF, lower, yep, upper, negative 2, degrees of freedom, 36 minus 1 is 35, paste. So 0.026 approximately is our p-value. We didn't use the table, and we're not going to. It should say calculator. Yeah, okay. So here, and then conclusions, just like we wrote for the test for proportion, same deal. Because the p-value, 0.02 whatever, is less than alpha equals 0.05, we are, Mills, mess up. So good thing that I made this mess up, because it happens even to me. Going back to the hypotheses were two-sided test, because mu is not equal to 320, so you have to double the area. So I have to double that 0.02 that I got from the calculator to get the p-value. So the p-value is actually a little bit more than 5%, so we fail to reject the null, which means we don't have convincing evidence for the alternative, that the true mean amount of this active ingredient is different than 320 milligrams. So perfect example, when you see that not equal to, maybe you just write a big ×2 in the do step and you know, all right, I got to make sure I double the area to get the p-value. Glad I made that mistake. All right, they're going to formalize things here. We kind of just went through it. At the end of the plan step, you're going to have a one sample t-test. One sample t-test for the mean. This is just going through an example. If they give you the raw data, just like in section 8.3, you're going to have to plug it in a list. You're going to have to create a box plot or a dot plot. You're going to need the sample mean and the sample standard deviation for your test statistic. It's more of the same. Okay. Sometimes you're going to see this in a computer output. So let's go through this. You see the true mean they're claiming is 5 versus the alternative that's less than 5. The sample mean 4.7, the sample standard deviation 0.94, and the sample size is 15. That gives me a test statistic of negative 0.94 and a p-value of 0.18. So that's all information you should be able to process and then use to potentially write a conclusion. All right. So this is going to be the same deal. I'm not going to go through and plug all this in my calculator. I'm just going to go through the main parts. So you might want to pause the video and go through the main parts of the 4-step process and then come on back. So for the hypotheses, this professor believes that students are getting less than 8 hours of sleep. To test his belief, he has a random sample of 28 students. Okay, so the null hypothesis would be mu is equal to 8. The alternative, he believes less. Mu is less than 8 hours. What is mu? Mu is the true mean amount of sleep that students at this school are getting. So that's the state step, the plan step. C, random sample of 28, check. V, 28 is less than 10% of all students at this school. Check, as long as there's 280 students at the school, seems reasonable. S, this sample size is less than 30, so I would need to plug this data into my calculator and create a, box plot, or I could just by hand create a dot plot and look, do I have severe skewness or not, and outliers. I'm assuming I don't, because they haven't told me otherwise, but you do have to show that. And then I would say the conditions are met. I'm going to do a one sample t-test with 27 degrees of freedom. And then for the do step, I'm going to have to show the answer because I am not plugging this in the calculator. All right, I have to get my sample mean from doing one variable statistics. Same thing with sample standard deviation. So then I'm going to take the 6.6 minus 8 divided by this 1.9 divided by the square root of 28. That'll give me this test statistic. And then I would use normal I would use, as my phone speaks, I would use TCDF from -infinity to this value with 27 degrees of freedom to get the p-value. So really small p-value, it's less than alpha equals 0.05. We reject the null. So we have convincing evidence that the true mean number of hours of sleep is less than 8. So looks like at this university that is indeed the case. Two-sided tests. We really kind of talked about this. The only thing that's different is when you find the area under the t-distribution, you double it to get the p-value. That's all that's going on there. All right. Is there a connection between one-sided tests and confidence intervals? Let's take a look here. This is for a two-sided test. All right. They claim that the mean blood pressure for males 35 to 44 is 128. So they take a random sample of 72 and they do a test and a confidence interval. Do the results of the test give convincing evidence that it differs? Well, the national average is 128. The test, if I look here at the p-value, this is greater than 0.05, so I'd fail to reject the null. We don't have convincing evidence of a difference. That's what's happening there. All right, they're going through the whole thing here. P-value is greater, fail to reject. All right. Interpret the 95% confidence interval. So we're 95% confident that the true mean blood pressure for males 35 to 44 is between this and this value. Explain how the confidence interval leads to the same conclusion. 120 is within our confidence interval. So we don't have convincing evidence that this true mean is different than 128. So that's that. So you can use if you have a two-tailed test, you can use a confidence interval to say like the null value is in the confidence interval, which means you fail to reject the null, or the null value is falling outside the confidence interval, which means you would reject the null and you'd have convincing evidence for the alternative. Last part of this section is talking about inference for means when you have paired data. Paired data comes from a matched pairs test, or matched pairs experiment, I should be saying. So some kind of experiment where they pair two people up, or it's the same person receiving both treatments. So this looks like they took people who were on the, let's see, what it actually, the effects of caffeine withdrawal. Some people took a placebo, some people took the capsules containing their normal caffeine, and they wanted to see did it increase depression. So here goes. Each subject took both the placebo and the caffeine pill, and we looked at the difference in their depression score. The higher score showed more symptoms of depression, I believe. Yes. Okay, so it's paired. Each person is getting both treatments, and then we look at the difference for each. You have positive and negative differences. They're taking the placebo minus the caffeine. So 0 minus 1, that's why that's -1. Okay. Carry out a test. Now, you'll notice here the state step is slightly different. We use mu sub d to represent the true mean difference. So the d, we have to define what is that difference. What is the order that we're doing the subtraction? It doesn't matter which way you do the subtraction, you just have to communicate it to the AP reader. So here, placebo minus caffeine, you would state that out. Mu sub d is the true mean difference, placebo minus caffeine. Plan step. This is the first time we've seen this, the random condition. Now that we have this is coming from an experiment, so there is no random sample. So we would say that the researchers randomly assigned the subjects to placebo or caffeine. Or I could generically say there was random assignment to placebo and caffeine. 10% condition, we don't need to check at all. Remember, we check that because we're sampling without replacement. Well, in an experiment, there's no sampling happening, so we don't check that. The normal large sample condition, 11 is not greater than 30. They didn't tell us anything about the shape of the population. So you'd have to look at the 11 differences. I'm only focused on these differences, putting those into a list and looking at a dot plot or a box plot. I see no strong skewness or outliers, so we're good to go. So conditions met, we're going to do what's called a paired t-test with degrees of freedom equal to 10. It's the number of pairs minus 1. And then for the do step, that's going to be, they didn't really show their work, but same idea. Oh, here it is. The mean difference, which comes from doing one variable statistics on that list of differences, minus the null, we're claiming there was no difference, divided by the standard deviation of the differences over the square root of the sample size. And then what I would do is I would use TCDF to get the p-value, which in this case was pretty low. So we'd reject the null. There's convincing evidence that the alternative is true. So that's your 4-step process. This is all the same. I don't think we need to go through another one. But just understand, you're going to have two different types of tests here. You have a one-sample t-test, and then you have the paired t-test. And the paired t-test is if you have a matched pairs experiment. All right. Determining sample size, no. Power. Okay, this is just talking about power. We've talked about that before. Case closed. I think that's going to be it, and we'll hit the summary. Yep. All right, so conditions are the same, random and 10%, but then because we're dealing with means, it's normal and large sample. That's how you calculate your test statistic. Remember, if this is a paired t-test, It's just going to be the mean difference and the standard deviation of the difference. So that's it for section 9.3. Enjoy.